Hi, everybody. Here's a short explainer video for day 2 of the programming bootcamp. Let's open the Jupyter Notebook or day 2 on GitHub. We'll view it on GitHub. We won't actually open the notebook. It's very possible that by the time that you watch this notebook would have been updated a bit with some typo fixes and some nicer formatting. But anyway, the content is still here, and that's what we're doing in day 2. So we've already seen in day 1 some if, else statements, but we see a bit more of that, okay? And then we do a bit of a game, a bit of a math guessing game, where we can actually get some random inputs, random numbers, X and Y, and we ask the user what is their sum, and we test the user, okay? This here is a Unicode character. You can copy it from one here in one way or another. You can discuss what Unicode is on that day as well. All right, so your first task would be to just take this program and adapt it to handle multiplication problems instead of addition. That's not a big deal. And then in day 2, we get to one of the most important things that we'll ever see, and that's actually making the computer doing something again and again. And in this case, this is a for loop. So we'll learn about a for loop, or one form of this for loop, where we do this print hello statement 3 times, or we do it 3 times, and then each time we actually know at what iteration it is, iteration 0, 1, or 2, or maybe we can change it to run from 1, 2, and 3, etc. So we'll play around with for loops, and we'll do some computation with for loops as well. So your second task is to actually adapt the math quiz function that you had above to see if a user can guess the total of the first n numbers. So we tell the user, hey, what's the total of 1 plus 2 plus 3 plus 4 up to, say, 10? Okay. And of course, well, if the user is a smart mathematician, then she will know that that's 10 times 11 divided by 2, which is 55. So there's no need to actually compute that. But we'll actually check the user if that's correct. But we won't use that formula, but rather use a for loop to compute this sum. Okay. All right. We'll then see that we don't have to just loop on numbers. We can loop on anything in a something that is iteratable, in this case, a list. So here's a list of strings, and we can loop over that. Okay. And we'll see all kinds of variations of that, of things that we can do with that. We can also index things through the index, of course, and we'll see the enumerate statement. Not clear to me if it's actually a statement or a function. You could speak about that with the instructors or tutors, where you both enumerate on the elements of the list and their index. Okay. Question mark on the function randint, which comes from the random package, and then we'll do something with randint. So what this task is going to be here is to write a program that finds the maximal and minimal number in an array, in the array numbers. That array should actually be a list. The word array, I say array, but no, in Python, we're here dealing with lists, with the list numbers. Okay, so we can do that by running a for loop on the list and actually all the time seeing if there's a new minimum and a new maximum. Okay, so a program that does that, that's good practice to do. A bit of a for loop, a bit of a conditional statement, etc. Then in this next task, we'll go to something called the Hailstone sequence. Okay, so that's a sequence of numbers where you start at some number x0, and then your next number, depending on the previous number, is the previous number divided by 2. If the previous number is even, that's a mistake here. This should be xn even. Okay, so the previous number is even, or it's 3 times the previous number plus 1 if it's odd. So for example, if the previous number was 7, 7 is not even, 7 is odd. 3 times 7 is 21, plus 1 is 22. Your next number would be 22. Okay. So the task is to write a function that produces the first 30 numbers in this sequence. Okay. So to run through the sequence and produce those first 30 numbers. Okay. Now, there's also something called a break statement, and we'll explore it here. A break statement actually stops you out of a loop. Okay, so often you involve loops and conditional statements, and if this statement happens, then the loop stops running. So you could play around with this code. Now, in the next task, you'll write a program that gives the user 5 math questions, and kind of similar to what you did at the start of this day. And if any question is wrong, then you stop it. but otherwise they reach the fifth one and they're victors and they win. Okay. Less common than the break is also the continue statement, which continues running the loop but doesn't execute the code below the continue statement in the loop. Okay, so now we're going to learn the second type of loop, which in a sense is more general, and that's called the while loop. So what the while loop does, it takes a condition and it keeps running the block of code under it as long as that condition is true. Okay, and that's pretty good for something like this hailstone sequence, because a hailstone sequence, you'd want to run it until you reach the number 1. Okay, so that's what we do here. Okay, here it is actually for the hailstone sequence. And we'll play around. We'll see that it's easy to get stuck, because have you ever seen a computer program that hangs, that gets stuck? Well, maybe it's actually running inside some form of while loop that's always true and not stopping just doing the same statement x equal 3 an infinite number of times, or many times, and getting stuck. Okay. We'll also explore the concept of having a loop within a loop. Sometimes you can have a loop within a loop within a loop. That's not a problem at all. So here you have it here, and we'll play with that. Okay. Now, in this task, we'll continue celebrating this hailstone sequence. Okay. And we'll want to see what initial condition to the hailstone sequence up to, say, the number 1,000, okay, so started at the number 2, 3, 4, 5, up to number 1,000, yields the longest sequence, okay? For example, if I would start it at 4, my sequence would just be 4, 2, 1. That's not too long. But for example, I think if you start at 27, it's quite long. But I wonder if there's a bigger one up to 1,000, okay? So the length of the sequence. So of course, you'll need to do some looping and some counting there and some conditional statements. Now, here is something to know. A for loop is just in a sense a kind of very special case of a while loop. So you can always convert a for loop into a while loop. Can you do it with this code? So here's a loop over the names. Try to say you only had while loops. How would you do this with a while loop? How would you execute this code with a while loop? Okay. And task 2.8 is just here. Now, it seems small, but it's a classic task, but it's actually a good exercise. And since you understand prime numbers, a prime number is a number greater or equal than 2 that's only divisible by 1 in itself. Well, write a program that gets some prime number, either from user input or you pre-specify the number or something like that, and tells us if the number is prime or not. Of course, there are better ways to do this, less efficient ways to do this, etc. So that's this task. Okay. Of course, it involves some looping. Then in task 2.9, consider something called the Stirling approximation. So there's a link to Wikipedia here of Stirling approximation. It's an easy expression that approximates factorials that's asymptotically equivalent to factorials. And let's actually look at it just for a sec. So here's the Stirling approximation. So n factorial is asymptotically equivalent to this. That means that if you divide n factorial by this and take n to infinity, that ratio goes to a constant. Okay, so what is the difference between the two? It's only an approximation, so there's a difference. Okay, so write a program that prints some table that does the relative error. Okay, so the difference between the two divided by n factorial. Okay, and here you might need to use the exponentation function in pi because these things are in Stirling, but you'll find out how to do that. Okay, all right. Now we're going to work in buckets. So that's just some different idea, something else. All right. So first of all, there's some inbuilt function ord, which takes a character and then returns us the ASCII code for the character. Okay, or Unicode is a generalization of ASCII code. So we'll speak about what ASCII code is. And there's also, in a sense, an inverse function that gets a Unicode or an ASCII number and returns the character. So then we have some text, and here the text is a string, but this is a multi-line string. This is how you do multi-line strings in Python. Okay, and what we do in this text is we kind of throw things into buckets. Okay, so you analyze this code and you basically count how many times each character appears. Okay, that's it. So then you'll make some variant of that, and that's the end of this day, and you'll write, and it was a big day. Let's see if you get to this task. So you'll write a game that challenges the player to write a sentence. So the player needs to input a sentence where no character appears more than 3 times. Okay. The longer the sentence and characters, the higher the score. Right. So we can write a sentence, I am God. I think no character appeared more than once. Okay, you can have a character appear up to 3 times, but the user can't go beyond it. Some sort of game that does that and does checking of this sort. That's a pretty good exercise. So that's a lot to do. Of course, by the way, I'm not got no claim here whatsoever. So that's the second day. Hope you enjoyed this day. Bye.